This is a slide deck I put together, a year or so ago. It's mostly current. The only thing we probably won't get to do much of a demonstration. It's a little difficult to do over a Zoom, but we'll cover the high points, try to make it at least somewhat exciting. So what we'll cover today, what digital voice is, how digital voice works, the popular digital modes used in amateur radio. We'll cover some other ones. Some caveats to digital voice, some things that it won't necessarily do, or expectations you could put aside. Reasons you might want to use digital voice. We'll do a mode comparison between all of them. We'll talk about registration and identification. Some of them have different requirements. We'll talk about digital simplex and repeaters using hotspots. And of course, questions and answers. And the brief demonstration, we'll try to get a few things in there, see how well things work. So we'll talk about some fast facts here, some important things that you'll want to know. The first thing is and most of these modes, really all of them, your voice is actually converted. It's sent into a fast shift keying, or for you technical folks, FSK format. So that your voice is turned into data packets. And it's, if any of you remember packet radio in the olden days, you could think of it that way. Your voice is put into a data payload and sped up, and it's sent with a vocoder. So the vocoder is a little chip inside the radio, takes your voice, turns it into a digital format, and sends it on. Most of these essentially have forward error correction. In other words, obviously it's a radio. You're driving down the road and you're going to go in and out of null spots. So there's a little bit of forward error correction so that you actually get everything as much as possible. In a lot of ways, that actually keeps a lot of voice continuity. And we're going to talk about that later. We'll see some examples of why that works out so well. So what else happens? So inside this data stream that you have, they add headers in there. Those headers add certain bits of routing data, payload data, subscriber identity. So in other words, who you are, and other synchronization information so that your digital radio, the other, if you have two radios back to back, you want to make sure you can get that signal across. So what mode exists in amateur radio? I think most of you know. If you haven't seen them, you're starting to learn about them, especially through your own club and some of your other local clubs. System Fusion, that's what you're running there on 443.9. That's also known as C4 FM. D-Star, we'll talk about each of these individually. DMR, a lot of you have probably used or heard about DMR. NXDN, this is not really used in amateur radio. It is a little bit, but it doesn't have the popularity of the other three. It's been kind of a Kenwood proponent. It's used in public service, but we budget conscious hams like to repurpose our equipment, so we're known to take good commercial grade modes and systems and put them into ham radio. And APCO P25. P25 is sort of on the realm of DMR. You could think of it that way. It's P25 is used in most public service around Western Pennsylvania. I don't know if Butler's using it yet. I think there's still an analog FM and UHF, but Armstrong County, for example, Indiana County, Westmoreland, actually Allegheny's still on. I think they're still part and parcel on FM and some other modes, but P25 is pretty popular, but not so much in ham radio. So why would you want to use digital voice modes? Well, there's a reliability factor. And I have a good infographic here to show you shortly, and we'll talk about the reliability. They actually, in many cases, digital voice can actually get into areas that FM cannot. And why? Well, forward error correction helps. when you have forward error correction, you kind of have a predictability of that signal. In other words, with the your radio knows what it's missing or what it lost. The ability to hear through a lower noise floor, you know, I think all of you have experienced this. If not, even you new hams know, if you've listened, someone driving down the road, they get into the fringe of the repeater and they fall out of the repeater. In a lot of cases, digital voice does not do that. It can actually hear into the noise floor better than the human ear can in analog. And the quieting that a receiver requires in many cases in digital works a little better. So not always the case, but in most cases, uh, that does happen. And again, I'll show you a little infographic here shortly that kind of demonstrates that. And we'll talk a little more about that. A lot of digital voice modes have enhanced capabilities. They allow for selective calling. In other words, you can, I'm just making a random example here on DMR, for example. You can actually put in the subscriber ID or basically the number of the other ham you're trying to call and call them directly across a repeater or even Simplex, for example. You can actually do it with every mode, but in which case, a lot of these radios won't even break squelch because the call is going directly from one person to another across the repeater, and therefore, since it's digitally squelched, it's subscriber to subscriber. You're not interrupting or necessarily tying up the voice channel or unsquelching other radios that don't want to hear that. And we'll talk about time sharing and other things here as well. Other capabilities. Some of you may have already seen this. You can send position data. You can send text messages. You can now send pictures in some of these modes and other data payloads that are pertinent. This is actually really works really well for MCOM. And actually, I think a couple folks here last month had brought that up and said, why would you use digital voice or why some of these modes? A lot of uh, a lot of abilities that come out of these in many ways that really helpful, a lot of fun. Simultaneous operations. So what is that? So some of these allow you to move voice and data at the same time. Since your radio is basically working in a data mode, it can break up the voice and data packets and send them simultaneously. You can move certain pieces of information, maybe a picture while you're talking, etc. Your radios more or less figure that out on their own and take care of handling all the protocol and header data. So this picture kind of helps a little bit. On the top line, the broken red line is a digital transmission, and the green line is a analog transmission. As you can see, this kind of drops off in a natural curve as you get further out from a repeater. For example, you have right here in between the broken dotted lines here in black is kind of where you would have a significant drop off on a typical repeater, for example. And you can see the digital transmission tends to fare better across that entire axis here. The digital cliff is one thing to watch out for. A lot of folks think, "Oh, I'm solid into the repeater, I'm good." A lot of times, your signal to noise ratio is pretty rough at that point, and you're into the fringes, and suddenly you just kind of disappear. So it's a little more dramatic. You can kind of tell when there's running out of range on FM, not so much on digital. Now, these are not actually completely to scale. This is just an example, but it gives you an idea of what you can expect in reliability and functionality when you're out there in the field. So now we'll come back and we'll talk about these popular digital voice modes as we know them in amateur radio. System Fusion, which all of you are quite at home with. This was championed by Yaesu. It's the new kid on the block. Out of all the popular digital modes, it's been the most recently developed and enhanced. I would say, being completely objective, I get a lot of lampooning because people say, "Oh, you were picking favorites." No, it really is by far the easiest to use. I call it if you remember the Ron Popeil rotisserie chicken cooker, set it and forget it. That's basically Fusion. When you buy the radio, you put your call sign in it, and you're done. Absolutely a breeze. D-Star. Uh, this was created by the Japan Radio League, essentially. This mode is almost 20 some years old, maybe more. It's been championed by ICOM. ICOM pretty much has every D-Star radio, less Kenwood, that has one handheld. It's the oldest digital voice mode in ham radio that, conventionally speaking, that we're using right now. I'm sure there are technically more that never made it, but as far as we're concerned, it's been around the longest. It can be a little cumbersome to use, partly because of its age and some of the capabilities it adds that aren't necessarily in Fusion, for example. The ability to send certain payloads and do distinct network routing from your radio. In other words, the ability to link and unlink repeaters and do certain other things from your radio makes D-Star a little more cumbersome. It is a little more advanced. Don't be scared of it. If it's something you're interested in, absolutely you can pursue it. But it has its learning curve. DMR uses an open standard. It's used worldwide. It's used in the UK. About every continent on the globe has DMR or some form of that. I think that's partly why it's so popular. Of course, it has commercial roots. It's championed by Motorola, Hytera. Pick a manufacturer, so they pretty much have DMR. And now into the what I call the third-rate commercial market. I mean, here's a good example. This is a Bofang Model 1702B, $60 radio. Technically not the most beautiful thing to look at on a spectrum analyzer, but for $60 in the ham world, who cares? So that's one reason it's been widely adopted. It can be sophisticated. We'll talk about that. We'll kind of do a little more of a mode comparison so you can see under the hood of these. But it's very manageable. There's a bit of a learning curve. I think some other folks here can attest to, but once you get it going, it's pretty good as well. Okay, so that's kind of where we were dovetailing into. So this gets a little technical. I put it more here for the folks that geek out on this. So the vocoders, and some of this information I put here because I want to make a comparison and show you why some of these modes vary, and it's because of the underpinnings of the chipsets and the other technical things that go into them. So the vocoder just uses an AMBE plus, so nothing really exciting here. Basically, what this kind of hints at is a later generation vocoder, plus the vocoder supports certain bits of data here. In the big picture, day to day, it's not going to matter. So forward error correction, System Fusion does voice and data in D-Star, right? We talked about those a little bit. These have distinct payloads, data payloads. DMR really sends no data. I don't want to say that's not technically true. You can send text messages on DMR. You can send a little bit of APRS. But as far as forward error correction and data streams, it's pretty much voice only. Modulation, Fusion's called C4FM. That's continuous 4-level frequency modulation. D-Star uses GMSK. Again, this is Gaussian minimum shift keying, and DMR uses 4-level frequency shift keying. So these are kind of similar. DMR and Fusion can actually be transcoded one to the other. In other words, you can do mode conversions on some of these hotspots, which we'll talk about here later, and that gets interesting as well. Multiplex method. Okay. System Fusion uses frequency division. Same for D-Star. DMR uses time division. And we'll get to see what the time division turns into. Transmission rates. Okay, so kind of, if you think about packet, 4.8 or 9.6 kilobits per second. D-Star uses 4.8 kilobits per second, and DMR uses, it can do 2 channels at once, so it'll do 4.8 plus 4.8. That's mostly straightforward. Whoops. Let me go back there. Sorry about that. Bandwidth. This is technically incorrect. I need to fix this. I have made the discovery. Fusion is supposed to run 6.25 kilohertz, but it's actually much wider. It's even a little bit wider than 12.5 kilohertz, but for all intents and purposes, we'll say it's 12.5 kilohertz. D-Star normally uses 6.25 kilohertz, although some radios I've seen run a little wider in a spectrum analyzer. At least they should be spec to these rates. DMR uses 12.5 kilohertz. Channel support. Okay. One voice and one data, one voice and one data, and 2 voice. Technically, DMR does add data payloads like text messaging and whatnot, but it's more or less part of the voice channels. So that's kind of interesting to know. And one of my next points will talk about why this is kind of interesting and semi-important. Unfortunately, I've had a problem with this slide deck. I have sound samples, but they won't play over the Zoom audio. So I try to let you listen to them so you can see how they actually sound across an FM radio, but that's not working. So I apologize. So let me just widen this up here. Okay. So System Fusion, basically, what I'm trying to differentiate here is why these are not directly compatible. People say, well, why won't a Fusion and a D-Star and a DMR radio work? Well, they have different payloads. And when that data payload is sent, it comes in a big package. Your entire transmission is basically this entire stream. System Fusion, just to give you an idea of what's happening, it sends synchronization bits, basically to tell the other radio, hey, I'm about to make a transmission, listen up. It sends some control flags in there, which ride on top of the sync bits and kind of says, okay, I'm about to send data or voice or whatever. Then it sends identification data, for example, your call sign. And so the data payload, more or less coming from System Fusion, which this happens several times in a few milliseconds, of course, is data, voice, and a checksum, data, voice, and a checksum, et cetera, et cetera, et cetera. And then it ends with a big fat checksum. So basically, this checksum isn't necessarily used for voice at that point because it's adding a summed checksum as it goes here. But this is important for the data portion of your payload. D-Star is pretty similar, except it sends a checksum at the beginning, and then the payload is basically alternating voice and data and a checksum at the end. So this gets interesting because while Fusion sends checksums along the way to ensure data integrity, D-Star does not. So if you are in a rough area where transmissions aren't getting through, and you say, why does Fusion work where D-Star does not? Basically, the payload has a differentiation here. Now, there's actually a lot more going on here. I've watered this down. I actually read each protocol, which was very dry and boring. But I wanted to demonstrate what's happening with these in case you experience them in the field. DMR is a lot more fun because it's time multiplexed here. DMR more or less does similar things that Fusion and D-Star do, but it has a data synchronization at the start, which is more or less where your text messages and things would go, and then it sends your voice payload. Now, why is this important? A lot of DMR repeaters can handle two voice channels simultaneously, and you can see I have them alternated here with colors. So this would be slot 1, and this is slot 2, and this repeats over and over. And part of that, people say, well, how does that actually work? Well, since it's fast shift keying, and you have two channels at once, the voice synchronization, depending on which time slot you choose, will keep all radios operating on one repeater, for example, synchronized to where they can both run simultaneously. So that's what makes DMR very unique, and part of the allure of why a lot of people have DMR repeaters. They can run two voice channels at the same time. So that's a fun thing. Yeah, and these won't, I don't think these will play. Let me try this. Yeah, that's playing out into my speaker here. So I wish I could get that to work better. Okay, so we kind of glossed over this, at least for Fusion. So some of these modes require that you sign up and enter your call sign or get a particular ID in order to use the network. Part of that is for security purposes. Part of that is the way the protocol is built. Um, for example, System Fusion, again, very easy. You can buy a Yaesu radio, get it out of the box, set it up, just the radio itself. No others setup or registration is necessary. So for Fusion, no problem. You enter your call sign. Um, Other operators are identified in their transmissions by their call sign. It just shows, right up on your display. When you transmit, it goes out, and when it comes in, it shows whomever. D-Star, D-Star is a little more complicated. D-Star, if you want to participate in the global network of repeaters and what have you, and reflectors, which we'll talk about, then you have to go sign up. Usually in Western Pennsylvania, most folks use the North Hills Amateur Radio Club site in order to do that. Um, Pretty much every geographical area has a registration site. Those are all tied together so that you are able to use your call sign across the entire global network. Um, the process only takes a few minutes to do, usually requires approval. Someone moderates that to make sure, for example, silent keys call signs aren't being harvested and used. Um, but in the case of the radio, when you program your radio, it's similar to Fusion. You enter your call sign through the display or the programming software, and you're identified to other operators by your call sign. So um, there's nothing very special that you have to do in order to get an identifier. Okay, DMR. This one gets fun. DMR, since it was a commercial standard and was used by a lot of public service agencies and other groups, it was never necessarily intended for amateur radio. So, and most units out there, police departments, fire departments, they don't use. They're identified by number or some other numerical ID. So, DMR radios usually use a 7-digit ID. Those are managed. There are 2 or 3 entities really that manage those numbers worldwide. And so for DMR, you basically go out to a site, radioid.net. You register. You say, I am, for example, I'm John Lewis. My call sign is AI3I. You enter everything in the form. And in most cases, almost instantly after they verify that you are who you say you are, they assign you a 7-digit ID. You are then part of the worldwide database, and then you're able to use that 7-digit ID and program it into your radios. Now, because of that, most DMR radios have to be able to hold a large database of numbers to call signs to translate those. So you'll find a lot of DMR radios, you have to pull in a database to associate the two. Otherwise, if you don't, you'll still be able to talk and use the radio, but you'll see a 7-digit ID and not know who the person is that's calling. Of course, you can just ask them for their call sign, not a big deal. But that's kind of where things get interesting, and those are the major differences. So far, I know some of you are sitting at home going, "Oh my, this sounds awful. I don't know if I could do this." There's a lot of help out there. I'm here. There are lots of folks who've been down this road. So don't pull your hair out if you say, you know what, I'm really interested in this. I want to try it. I want to experience it. No problem. Get in touch with me. If there are folks you know here in the Butler County Amateur Radio Public Service Group, reach out to them. But by all means, ask for help. You'll get it, and in spades. Um, Here's some other things to look at too. Um, so just a comparison on how these modes work and how you can use them. Um, Obviously, can you talk on Simplex with all these modes? Yes, you can. You can basically um, Fusion again is the easiest. You can just pick Simplex. I think it has an automatic mode select for most cases. You can turn it on, and there you go. D-Star, yes, it does Simplex, no problem. DMR also does, no problem. D-Star and DMR, you kind of have to supply a little more information to your radio in order to do that. And DMR, you have to pick a talk group. We'll talk about talk groups and whatnot later, but yes, you can do all that. Can you talk across repeaters? Yes to all of them. There are, as you're now intimately aware as a club, you have a Fusion repeater. Um, there are lots of Fusion repeaters. I don't know if any of you remember the history. Yaesu was selling Fusion repeaters to ham clubs for $500 a pop a few years ago, and they sold like hotcakes everywhere. So more people than not have Fusion repeaters, and it's gaining a lot of adoption for that reason, I think. D-Star, there are D-Star repeaters. They've mostly been phased out in terms of they're not commercially selling them right now, but you can actually use third-party software and your own hardware to make your own D-Star repeater. You can actually do that with Fusion and DMR as well. And of course, yes, there are DMR repeaters. They're very plentiful because they are very much in the commercial world and industrial sector. So you can get them for a song on eBay too. Automatic mode switching. This is a big seller for a lot of people, and understandably so. Yaesu Fusion radios will switch from analog to digital if they detect a digital signal. In most cases, there's a button to turn that automatic feature on and off. D-Star and DMR will not do that. You have to manually pick whether you want to be in digital or analog mode. In a lot of cases, that's not a problem for folks because they know what mode they want to pick. But in your case as a club, if someone has an F or conversation on FM and then they move right to Fusion, that can catch people by surprise. So there are a little bit of operator formalities and customs that most people adopt within their club. What else? Selective calling to other stations. Yes, you can more or less selectively call with all these. DMR has some caveats. DMR, I would say the biggest caveat is being on the same network at the same time. D-Star lets you call pretty much across the entire network and make selective calling at any time. System Fusion, it depends where you're tuned into, but essentially, yes, you can do selective calling, no problem. What else? Remotely linking repeaters by radio. So this is something I kind of glossed over earlier. This is why D-Star is sort of complex in its nature because it adds extra features to let you link and unlink to reflectors, which we'll talk about next. Yes, you can do that with D-Star. System Fusion and DMR, for the most part, no. They are what they are out of the box. Multi-repeater connections. Can you create networks and tie systems together? Yes to all three of them. In parentheses, we have the nomenclature for creating talk groups, essentially, or rooms, what have you. WiresX facilitates this function on System Fusion. In D-Star, you'll hear them called reflectors, and DMR, they are talk groups. Essentially, they're all the same thing. It's a uh, group call, group channel type of thing. So you're able to talk to multiple parties at one time. Hotspots. Okay, so I kind of glossed over um, hotspots. I didn't really talk about them. I showed you a little picture one. This is a little Raspberry Pi. We'll talk about what they are. Uh, so there are several out there that I'm sure you've heard of or probably used. And so hotspots, these little guys, they're basically a tiny micro repeater. So if you don't have a D-Star or DMR or Fusion repeater in your neighborhood and you want to get onto digital voice modes, these little guys do the job. Uh, this is this is a microcomputer. It's called a Raspberry Pi. This is a Raspberry Pi Zero W, to be specific. And what that is, it's a little computer. It has a little computer board on top of it, and that computer board has a radio transceiver. In particular, this little guy runs on UHF. Here, I'll try to stick it here in your face so you can see it. And these little guys retail for about $150. And this is a multi-mode device. We talked about modes earlier. This does DMR, D-Star, System Fusion, P25 and NXDN. So it does everything. And that's nice for the fact that you get a lot of bang for your buck. There's not much in the way of technology obsolescence. You can buy this, and whether you have a DMR radio or a Fusion radio or a D-Star radio, it's able to do the job. They make these in two variations. You can get one that does simplex or duplex. Duplex is like a repeater. You would assign an input and output frequency to it, and they're essentially the same. There's no greater benefit to having one over the other, really. I've found. I've tried them all. The most common ones. This is basically a Zoom spot. Zoom spots are predominantly sold on ham radio outlet. If you're trying to find a retailer that carries them, they're probably the easiest place to find them and get them shipped to you at a competitive price quickly. No, I'm not advocating any retailer. I'm just telling you where to dig them out. Open spots, also a nice unit. I haven't. I've played with them very little. They tend to be a little more expensive, but they have. I understand from folks they have a very nice interface to use. These are actually all configured from a web page. By the way, I should have clarified that. This also connects to your home network using Wi-Fi. So your internet connection is made from Wi-Fi, and then from there, your connection to your radio is made over RF. So um, the open spot I understand has a much nicer interface and easier to use. The Zoom spot is similar. I'll show you what the Zoom spot looks like so you have an idea. And then there's a jumbo spot, and a jumbo spot's kind of something you make on your own. You use the instead of having an integrated radio, you basically get your own microcomputer and a digital modem, and some folks interface those to a simplex radio. So you basically build yourself a repeater, but is um, on simplex. And some people do that and serve their whole neighborhood using one of those. And that's basically a megaspot. So this is kind of I took a screenshot of the web interface that these little hotspots run, just so you have an idea. This is that's my old call sign. I changed calls here a couple years ago, but um, this this hotspot gives you a complete web interface. You can see everything that's going on in real time. You can see people who've called you, what mode they've called you on, and your screen may not show you in great detail, but you know. I had this running in the middle of winter one day. I had calls on D-Star and System Fusion, on DMR, and it was able to keep up and manage, well, not simultaneously, but in serial succession. It was able to follow conversations as they progressed throughout the day. So pretty amazing here. I have radios of every digital flavor here to experiment with because I get a lot of questions and phone calls. So I try to keep up with the latest advancements here in amateur radio. So that kind of comes to the end of my presentation here. I think I'm about on time. I know I rushed through that. I know folks have questions, and I hope I didn't put anyone to sleep. I wanted to give you kind of an overview of what's happening, but also a peek under the covers on a technical level so you understand just what these little devices and what these radios are doing. So I hope so far that hasn't been too much information overload. So I'll open it up now for anyone who has questions.